Let us see some important points in units and dimensions. You know that there are 4 systems of units. One is CGS system, another is FES system, third one MKS system, and fourth one SI, System International. But now we are using SI units. In SI units, there are 7 base units: meter for length, kilogram for mass, second for time, ampere for current, Kelvin for temperature, candela for light intensity, mole for amount of substance. You know that there are 2 supplementary units in SI. One is plane angle, the unit is radians. Another is solid angle, the unit is sterdian. Then there arises one important question. What about the total solid angle subtended at the center of a sphere? The question is, what about the total solid angle subtended at the center of a sphere? We can calculate the solid angle by the formula surface area by radius square. Surface area by radius square. Surface area of a sphere is 4 pi r square. Therefore, solid angle is 4 pi r square divided by r square equals 4 pi sterdian. That is, the answer is the total solid angle subtended at the center of a sphere is 4 pi sterdian. You know that new definition for meter is in terms of velocity of light. The new definition for meter is in terms of velocity of light. Another important thing is that the new definition for second is in terms of vibration of cesium-133 atom. In addition to these units, there are other units for length. One is Fermi or femtometer. You know that one femtometer is 10 raised to minus 15 meter. Another unit is Armstrong unit. One Armstrong unit is 10 raised to minus 10 meter. Another unit is astronomical unit. One astronomical unit is 1.5 into 10 raised to 11 meter. Another unit is micrometer or micron. 1 micron equals 10 raised to minus 6 meter. Then usually there arises one question. Parsecond is the unit of. Parsecond is actually the unit of distance. 1 parsecond is 3.08 into 10 raised to 16 meter. You might have heard of light year. Light year means distance traveled by light in 1 year. 1 light year equals 9.5 into 10 raised to 15 meter. 1 light year is 9.5 into 10 raised to 15 meter. There are some standard units, standard concepts. That is, usually the thickness of a sheet of paper is 10 raised to minus 4 meter. Radius of the nucleus is approximately 10 raised to minus 14 meter. Another important thing is that lifespan of an excited atom is 10 raised to minus 8 second. Lifespan of an excited atom is 10 raised to minus 8 second. Then there arise 2 questions. One is, how many microns make 1 kilometer? How many microns make 1 kilometer? The answer is 10 raised to 9 micrometer. You can easily calculate that value. Another important question is, speed of light is 3 into 10 raised to 8 meter per second. What is its value in millimeter per picosecond? What is its value in millimeter per picosecond? The answer is 0.3. You can easily calculate it. One question asked earlier is, the value of G is acceleration due to gravity is 10 meter per second square. What is its value in kilometer per hour square? You can easily calculate it. The answer is 129600. 129600 kilometer per hour square. The value of G is 10 meter per second square. Its value in kilometer per hour square is 129600.
Integral, an institution for innovative teaching, medical and engineering entrance coaching, CPTCA entrance, crash course, private tuitions, brain development program for children from 3 to 14 years. Integral, Galaxy Building, Kattanam. 94475 66683 94471 05465.
Another portion in this section is dimensional analysis. Usually we write dimensions in terms of mass, length and time. But we can write dimensions in terms of temperature, Kelvin and current I. Let us see some important dimensions earlier asked. First one is angle. The dimension is m raised to 0, l raised to 0, t raised to 0. The dimension of universal gravitation constant capital G, m raised to minus 1, L cube, t raised to minus 2. The dimension of kinetic energy, ml square, t raised to minus 2. The dimension of coefficient of viscosity, eta, ml raised to minus 1, t raised to minus 1. The dimension of pressure is ml raised to minus 1, t raised to minus 2. The dimension of Planck's constant H, ml square t raised to minus 1. The dimension of h nu by c, ml t raised to minus 1. The dimension of thermal conductivity, K, ml t raised to minus 3, k raised to minus 1. K means Kelvin. The dimension of charge Q, I into capital T, I the current. The dimension of potential V is ml square t raised to minus 3, I raised to minus 1. The dimension of LC, that is the product of coefficient of self-inductance and capacitance, T square. The dimension of d rho v divided by eta, d the diameter, rho density, v velocity, eta coefficient of viscosity. These m raised to 0, l raised to 0, t raised to 0. That means it is a dimensionless quantity. Another question asked earlier is, Van der Waals equation is given by P plus A by V square into V minus B equals RT. What is the dimension of A? What is the dimension of B? What is the dimension of R? We can easily write the dimension of A as M L raised to 5 T raised to minus 2. The dimension of B is L cube. The dimension of R, the universal gas constant, ml square T raised to minus 2 K raised to minus 1. Then there arise certain questions. Quantities having same dimension, stress, pressure, modulus of velocity, all have the same dimension, m, l raised to minus 1, t raised to minus 2. The dimension of torque, work and energy are the same, ml square, t raised to minus 2. The dimension of impulse and moment are the same, ml, t raised to minus 1. L by R, CR, root of LC, the dimensions are the same. The dimension is capital T. 1 by root of mu 0 epsilon 0, velocity, dimensions are the same. The dimension is LT raised to minus 1. Strain, Poisson's ratio, angle, the dimensions are the same. Another is gravitational potential, latent heat, dimensions are the same. That is L square T raised to minus 2. Angular momentum, Planck's constant, the dimensions are the same. That is ml square T raised to minus 1. Then there arise two questions. One, if c is the velocity of light, g the gravitational constant, h the Planck's constant, be chosen as the fundamental units. What is the dimension of mass? What is the dimension of length? What is the dimension of time? We can easily calculate it. The dimension of mass is h raised to half, c raised to half, divided g raised to minus half. The dimension of L is h raised to half, g raised to half, c raised to minus 3 by 2. The dimension of t is h raised to half, g raised to half, c raised to minus 5 by 2. Another question is, if velocity of light is taken as the unit of velocity and here is the unit of time. What is the unit of length? We can easily calculate the unit of length as light year.